Okay, so all right. So today's class will be talking more of the advanced computer functionality. What does RAID do? The concept behind RAID. Okay, you find RAID most times in all the server rooms, all the MTN telcos, banks too. They do have this RAID because this is where they have a series of backup storage devices. Okay, big organizations use this. Google has the biggest one. Okay, they use these to make sure they back up. These are physical storage devices. All right, so let's look at what we have. They say storage devices can be grouped and managed to create large storage volumes with redundancy. To do so, computers can implement redundant array of independent disk. It's called redundant array of independent disk technology. All right, so RAID provides a way to store data across multiple storage devices for availability, reliability, capacity, and redundancy, or performance improvement. So in addition, it may be more economical to create an array of smaller devices than it is to purchase a single device of the combined capacity provided by the RAID. So, especially for very large drives, to the operating system, a RAID array appears as one drive. Okay, that's what happens. So the following term describes how RAID stores data on various disks. So, like you see in the diagram on the screen, it actually has different storage of different hard drive that is linked together. So on your system, it's going to be showing you one drive, but when you save, it keeps saving on the system. So we want to see how, the storage of a RAID works. All right. So we have the one we call stripping. This RAID type enables data to be distributed across multiple drives. This provides significant performance increase. However, since the data is distributed across multiple drives, the failure of a single drive means that all data is lost. That's for the stripping. Then for the mirroring, this kind of mirror RAID has type stores duplicate, okay? This RAID types stores duplicate data on one or more other drives. This provides redundancy so that the failure of a drive does not cause the loss of data. So the mirror can be recreated by replacing the drive and restoring the data from the good drive. So that's mirror. Then we have parity. Parity is another RAID type that provides basic error checking. That's what it does. And fault tolerance by storing checksums separately from data. This enables the reconstruction of lost data without sacrificing speed and capacity, like mirroring. So that's what parity does. Then we have the double parity. The double parity is a RAID type that provides fault tolerance up to 2 field drives. Okay, so the figure shows a large drive enclosure that could be used in a data center with one or more RAID implementations. Drive enclosures can use hot swappable drives. You can see the diagram. This means that a drive that fails can be replaced without powering down the entire RAID. Powering down the RAID may take the data on the RAID unavailable to users for an extended period of time. Not all drives and RAID types support hot swapping. So you can see that. So when you notice there's an error, you can just go and swap. That's it. So this is the concept between RAID. Is a storage, a very good storage, okay, which is not connected to the system. When I mean it's not connected, it's not, you can't find it, it's an independent array where you have different DICS technology, like the ones they are placing. It's just like you're putting a library, but they're all hard disk connected. Okay, so that is the work of a RAID. So let's proceed to the next. So what are the RAID levels? We want to look at the RAID levels that we have. The RAID levels that we have. There are several levels of RAID available. These levels use mirroring, stripping, and parity in different ways. Higher levels of RAID, such as RAID 5 or 6, use stripping and parity in combination to provide speed and to create large volumes. The figure shows the details about the RAID levels. RAID levels here, RAID levels higher than 10 combine lower RAID levels. For example, a RAID 10 combines RAID 1 and RAID 0 functionality. So let's look at what we have in the diagram. The RAID level 0 has a minimum number of drive 2. The features is striping. The advantages is performance and capacity. Why the disadvantage is all data is lost if one drive fails. Then we have RAID 1. RAID 1 has 2 minimum drive as well. Mirroring, okay. Then performance and reliability. Performance and reliability. Then we have capacity is half of total drive size. That's the disadvantage. Then we have what we call the RAID 5. The RAID 5 takes 3 numbers of drives. It has striping with parity. It has performance, reliability, and capacity. And it takes time to rebuild array if a drive fails. Then we have the RAID 6. RAID 6 takes 3 minimum drive, okay? Then the striping is a stripping and stripping with double parity, same as RAID 5. So it performs, it has performance, it has reliability, and it has capacity. And it takes time to rebuild array if one or more drives fails. Then we have the RAID 10, which is the highest, which says the minimum number of drives it can take is 4, okay? And performance capacity, that's the advantage, and high reliability is very reliable. Then the capacity is half of total drive size. All right, so RAID levels, you hardly see them except you work in an organization that has a lot of data storage, which they are doing physical data storage, okay? So you can have a RAID. And I showed you the diagram that this is how the diagram of a RAID looks like, okay? Combination of different drives, all right? So let's move to the next. We want to check our understanding, and let's see how we've actually okay. So it's actually coming up. Network. All right, so so we can come back to this because I know a lot of people did not. Let me see how many we have. We have 5 in the class right now. Okay, so let's proceed. We'll come back to this. All right. So we're looking at the legacy ports now. We want to look at all the entire ports you have on a computer system and their function. Okay. So we have what we call legacy ports. What does it mean? Computers have many different types of ports to connect the computer to external peripheral devices. As computer technology has evolved, so have the types of ports used to connect peripheral devices, Okay, so legacy ports are typically found on older computers and have been mostly replaced by newer technologies such as USB. All right. Why we want to talk about this is for us to see uh, the technology that we have, but many systems have actually replaced most of these ports with USB. Okay, but we still have to talk about it. Okay, let's look at the first one, which is the serial port. They call it serial port. You can look at the diagram we have there. The serial ports were used, you can see the terms, were used to connect various peripherals such as printers, scanners, and modem. Today, serial ports are sometimes used for making console connections to network devices to perform initial configuration. So there are two form factors of a serial port. We have the A9 pin and we have the DB9 port, okay, and a A25 pin port. So those are the two types of ports that we have. You can see the diagram is a serial, connection. Most printer uses it, but when you're in the networking line, especially when you have to set up a router, most of the router comes with this technology of serial. But most times now you find it that you in the latest system we always have the USB. All right, let's look at what the parallel does. Now the parallel ports have a 25 pin receptacle used to connect various peripherals devices. As the name implies, parallel ports send data in multiple bits at once. In parallel communication, because these ports were often used to connect printers, they are often called printer ports. This is a printer port, okay? And yes, many printers today use USB, okay? Like I said, USB has taken so much of these legacy ports, all right? But we still have to talk about it because as an IT person, you need to have the knowledge of all this. Then we have the game port. The game port is a 15-pin game port that was used as a connector for joystick input. Now, this is the connection you use actually to play a game, all right? Well, as of today, they've actually converted most of the devices with a USB, all right? So game ports were originally located on the dedicated game controller expansion slot, and then later integrated with sound cards and on PC motherboards. Okay, so don't be so surprised. You get to some systems, you see this, you still have many of them. So we have the PS2, all right? So the PS2 is a 6-pin connector used for connecting a keyboard and mouse. So shown are two color-coded PS2, purple for the keyboard and green for the mouse. If you've seen old systems, you see them comes with this port, but the latest system of today, they all have USB, okay? USB have been used to actually replace all. So we have the audio ports. Please, the way you have this diagram, that's how you have it on the system. Audio ports connect audio devices to the computer, okay? Analog ports typically include a line in port to connect to an external source, e.g. stereo system, okay? A microphone port and line out ports to connect speaker or headphones. So these are the ones you see that connects to Microsoft, sorry, I say Microsoft, microphone ports, okay, and headphones. While most times these two are used for stereo system, okay? So these are the legacy ports. Please note, all of them has been replaced with USB, okay? Because USB, most people producing all the equipment they are producing today prefer the equipment to have a USB port or a USB connector rather than putting a different peripherals port. Okay, so it's called a legacy port. Don't forget. All right, we move to the video and graphic ports. Video and graphic ports. Graphic ports are used to connect monitors and external video displays to desktop computers and laptops. Okay, so we're going to see the types that we have. We've actually identified before, but we just have to talk about it. So this is a VGA. A VGA is an analog port. Please take note of this, very, very important. A VGA is an analog port and is the oldest graphics port likely still used on some PCs, although it is quickly becoming a legacy technology, okay? VGA ports are colored blue and accept a 15-pin connector with the pin arranged in 3 rows, okay? So you can see the 3 rows here. That's how it is. They come in 3 rows, okay? And they are 15. All right, so let's move to the next one. So we have what we call the DVI. The DVI is an emergency of digital displays, such as LCD monitors, TV LED, to the development of the DVI for transmitting uncompressed digital video. You find this in most projectors, okay? So variants of this DVI interface are configured to support multiple transmission modes, okay? A DVI-A, which is analog, supports analog only, while a DVI-D, which is digital, supports digital only. And a DVI-I integrated supports both digital and analog. So there are also 2 forms of DVI connections. The single link connections that use a single transistor, minimize differentiate, it's actually minimized, okay? So that support digital only. There are also 2 forms of DVI connections. The single link connection that use a single transition minimized, okay, differential signal, which is TMDS transmitter, all right? And the dual link connection that use 2 TMDS transmitters to provide higher resolutions to larger monitors. So this, you see all those LCDs you see outside that has been placed. Those LCDs, those billboards you see on toll gate and all that, they all have a display port that is called DVI. This is what can enable the display multiple displays. So this is the kind of port they have, and their systems too. We have this port. So if they have a desktop there that is connected, all they need to do is to connect the desktop, run the software on the computer system, and leave it, and it keeps running continuously like that. All right, so let's look at the next one. This is common to everybody. Everybody knows this, but I'll talk about it. It's called HDMI. HDMI carries the same video information as DVI, but is also capable of providing digital audio and control signals, okay? HDMI uses a 19-pin connector. Smaller portable electronic devices have a smaller 19-pin mini HDMI connector. So this is the connection to your HDMI. So we want to talk about the display port. The display port is a newer technology designed to replace both DVI and VGA. So if you get your laptop and you find out your laptop is having this display port for connecting computer monitors, so you don't have to be going for HDMI all the time. You can use a display port. So the display port uses a 20-pin connector, okay, for delivering the high bandwidth video and audio signals. It's just like HDMI. So there is a miniature version of the display port called the mini display port, which is primarily used on Apple computer. So if you get an Apple computer, you find out that it has this particular connector. The connector always look like HDMI, but it's not HDMI. Okay, I think I mentioned it the other time. You can see how it is. Most HP laptop come with this connector. Okay, but it doesn't work with your, if you want to buy the cable, you have to buy the cable separately. It's not HDMI, it's called DisplayPort. All right, so please, let's take note of that, because a lot of people always think it's HDMI. HDMI port is always, you can see it's always more like a rectangle, you know, you can see the shape, but when you look at this one has one side to be square and the other side to bring out more like a rectangle shape. So it's two different, but they're serving the same purpose. Okay, please take notes. Then we want to talk about the USB cables and connectors. We've seen a lot of USB cables and connectors, but it's important to identify them and know the type of USB. USB are very different. Like I always tell people, don't just think you bought a flash drive. It must enter any hole that looks like USB. They have different speed, and we're going to talk about it right now. So USB cables and connectors. All right. Over the years, the USB protocol, okay, has evolved. The USB protocol has evolved, and the various standards can be confusing, which is very key. Please take note. There's a USB 1.0. This 1.0, if you find a port on a computer and you plug your USB and you see it rolling and rolling and rolling, just know it has a USB 1.0. It provides a low speed transfer. Its transfer rate is at 1.5 megabyte per second. Okay, so most keyboard always come with USB 1.0. All right, and mouse, they always come with it. That's the design. All right, and a full speed channel at 12. Okay, so let's move to 2.0. So 2.0, which is a USB 2.0, made a significant leap, increasing transfer rate up to high speed at 480 megabits per second. Okay, so there's also a USB 2.0. So when you buy a system or when you buy a motherboard, please read through the manual to know which of the USB is on the motherboard. Okay, it's either a USB 1 or USB 2.0 or USB 3.0. So please note, many flash drives they sell today, they sell a 4.0 flash drive. So sometimes when you fix your flash drive on your USB cord, you find out that it's not coming up. But when you go and fix on another computer, it will come up. It's because the speed and the USB port that is actually being installed on the system has a higher version. So a 3.0 increased the transfer rate to super speed 5 gigabytes per second. You can see the speed. Okay, so USB 3.1 increased the transfer rate of super speed up to 10 gigabytes per second. Okay, and USB 3.0, which is the latest, we already have the 4.0 already. 4.0 is out already. The latest USB-C certification supports speeds of up to super speed plus 20. That means it's higher. It can transfer data within this period at 20 gigabytes per second. You can see the speed. All right, so it's very important. So let's look at each of the type. USB type A. This is we're talking about the cable now. We've talked about the USB port. So we're talking about the cables that connect. So you can understand, a lot of people don't know this, but this is how it works. This is a rectangular connector found on virtually every desktop PC and laptop, as well as TVs, game consoles, and media players. So USB 1.1, 2.0, and 3.0 type A connector and receptacles, and physical components. So this type A can work for 1.1, 2.0, and 3.0, okay? But cannot work for 4.0, okay? Then we have what we call a mini USB. The USB mini B connector is rectangular with a small indentation on each side. So the mini USB form factor is being phased out and replaced by the micro USB connector. Yes, you hardly see this kind of USB anymore. You know, you only find it in old iPod, old just all these old, even chargers. They don't use it anymore. What every device is used now. There are some phones that was using this connector before, all right, but now everyone now focus on the micro, which is the latest one that every devices, every phone manufacturer, they want to put a micro USB connector. Okay, so the micro USB connector is found on smartphones, tablets, and other devices, except for Apple. Most manufacturers have adopted the micro USB interface. The USB 2.0 micro B connector has two corners pushed in at an angle. You can see it there. That's what we're seeing on the diagram. Okay, it's called a micro USB. So let's look at a USB type B. This, you find this in most printers. Okay, cameras use it as well. So the USB type B connector is commonly used to connect printer and external hard drives. Okay, it has a square shape with beveled exterior corners and an extra notch at the top. You can see it there, the diagram you were seeing on the screen. Then we have the type C. I think I mentioned this. This is always confusing a lot of people, but Samsung product is the one. Most Samsung product come with the type C USB. So the USB type C connector is the newest USB interface. Okay, it is smaller than the type A connector, and it is rectangular with 4 rounded corners. Both Thunderbolt 3 and USB type C are an example of a multi-pose cable that can be used to attach different kinds of peripheral devices to a PC. So a USB type C is the shape of the port. Okay, Thunderbolt 3 combines the functionality of USB, Thunderbolt, DisplayPort, okay, and the ability to deliver power to devices through the cable. So that's what you're seeing right now, okay? It's called USB type C, all right? So when you have the USB type C, it's faster, okay, than the other type A and the mini and the micro USB, okay? So please take note of that. So then we have the final one, which is, we all know this, okay? It's called Lightning. It's called Lightning, all right? It's called Lightning. The Lightning connector is a small proprietary 8-pin connector used by Apple mobile devices, such as iPhones, iPads, and iPods, for both power charging and transfer and data transfer. It is similar in appearance to a USB Type-C connector. All right, please take note of this. So don't be confusing people as an engineer, okay? Although when you go outside and tell somebody, please can you help me with your lightning cable? Or like, what is it talking about? But please explain to them. All right, so it's called lightning. So we're going to talk about the SATA cables. If you have any question, please let's ask before I proceed. I know some of us came in a bit late, but if you have any question, let's talk about it now. All right, so I think we need to have a few conversation, okay, before Saturday, by the grace of God. So let's talk about SATA cables and connectors now. SATA cables, or the word SATA, is an interface type used to connect SATA hard drives and other storage devices to the motherboard inside the computer. SATA cables are long, up to 1 meter, and thin, with a flat and thin 7-pin connector on each end. So what you're looking at here is the connector, and that is the cable. So we're going to see the cable now. So that's the cable. One end plugs into a SATA port on the motherboard, and the other end into the back of an internal storage device, such as a SATA hard drive. The SATA connector has what we call an L, shaped key, so that it can only be installed in one way. So you can't make mistake. It's not something you want to plug. You can't say, okay, I was plugged. If you don't plug it with the L way, it will not enter. So that's what they're trying to explain there. So let's look at the SATA data, okay? Now we want to look at the SATA data. Okay, so the SATA cable does not provide power. So an additional cable is needed to supply power to the data, to the SATA drives. So what I'm trying to explain here, this only transfer data, all right? Okay, and the SATA hard drive doesn't come with its own power, so you still have to do a connector that connects. So this connector is actually a connector for power, all right? It's a connector for power. You can see the difference, okay? So there's a connector for power, all right? So when you're connecting, you must first connect the power cable, which is SATA, from your motherboard, from your power supply, okay? All right, so let's move to the next. So this is what we call the eSATA cable. The eSATA cable. Most of the time, this eSATA cable are always used for external hard disks. So eSATA is used to connect external SATA drives. So eSATA connectors do not have an L-shaped key like the SATA connector. However, an eSATA port does have a key feature to prevent inadvertent insertion of a USB connector, which is similar in size and shape. What are we saying here? What they're saying here is the connector of the mouth of the cable is not exactly like the L, but it has its own too, whereby if you don't connect well, it will not key to the motherboard. All right, so that's it. So we're looking at the adapter. This is the adapter. This is how the adapter looks like. All right. Often an expansion card is installed in the computer to provide eSATA port. That means eSATA ports most times does not come with a motherboard. So you have to buy an extra card, okay, to have it on the system. Please take note of that as well. So we are still under the advanced computer functionality. We're under the ports, connectors, and cables. And we want to talk about twisted pair cables and connectors. What cables are actually the twisted pair? So let's look at one. Twisted pair cable is used in wired internet networks and in older telephone networks. Twisted pair cable gets its name from the fact that pairs of wires inside the cable are twisted together. So the twisted of wire pairs helps reduce crosstalk and electromagnetic induction. Okay, so we're going to see different types, because as an IT person, you need to understand these cables. Okay, so we're going to see different types. We have the RJ45. This is common, and this is what you're going to be conversant with all the time as an IT personnel. You know, you'll be dealing with a lot of RJ45. So each RJ45 connector, each end up each end of a UTP cable must be terminated with a connector, which is part of the practical we're going to be doing when we get to the network. Okay, so it's part of the tools you're buying. Now there's a tool, your crimping tool. What your crimping tool does is to help you prepare this cable. So you're walking through a place, you saw that their network is having issues and they can't connect properly. You need to find a solution. And most times, solutions always come from the network twisted cable, which is the RJ45 mount. Either somebody has walked through, they have pressed it, the wire has gone this, the wire has done that, so it affects you. So this is how it looks like in the diagram. So in the case of Ethernet network, it is an RJ45 connector that terminates the cable and is plugged into an internet port. So that is how it looks. So when you buy it, it's always looking this way, where it has the green, the blue. It's now you that will carry the RJ45 connectors and connect it to this and make sure you key it down. All right. So when you key it down, it stays permanently and it sends signals immediately to the network. All this is a part of what we're going to be learning during the networking topic. So twisted pairs, there are basically two types of twisted pair cables: the unshaded, okay, twisted pair, which is UTP cabling, and the shaded twisted pair, which is STP. The most commonly used form of twisted pair cable is the UTP. UTP is what most technology, even if you buy a new all this radio, SpectraNet internet, that's what they use. They use the UTP. Okay, UTP is the most common one. It consists of color-coded insulated copper wires without the foil or braiding found in STP. All right. So this is how you do, and this is how you connect it. So when we get to the practical for networking, you see more of that technology. So this is called RJ11. So please don't miss RJ11 with RJ45. RJ11 is used for phone lines, okay? Intercoms, telecoms, they call it intercoms. All those intercom that always stay in the reception and is connected within the office. They use this RJ11, okay? So RJ11 is older telephone networks used a 4-wire UTP cable, all right, with 2-wire pairs terminated with a 6-pin RJ11 connector. The RJ11 connector looks very similar to the RJ45 connector, but it's smaller. So that's how you see the difference. It's always very smaller, all right? And the wires are not firm like you have it in the RJ45. So we'll move into the coax cable and connectors. Coax cables are cables we see almost every day. Your DSTV cable connecting from your dish outside to your decoder inside is a coax cables and connectors. So coax cables are always used for radio, for TV. All right, let's just look at it. Coaxial cable, they call it coaxial cable. Coaxial cable has an inner center conductor, usually made from copper or copper-clad steel, which is surrounded by a non-conductive dielectric, okay, insulation material. This dielectric is surrounded by a foil shell, which forms the outer conductor and shields against electromagnetic interference. Now, most times, if you fixed your decoder once before, you see there are some shining objects when you try to connect that when you peel off the cables, you see some shining objects. So they are trying to explain to us that those shining objects, the work they do is to reduce electromagnetic interference. Okay, so the outer conductor shed is encased in a PVC outer jacket, which is what we're looking here. All right. So you see the PVC outer jacket, which is the rubber. All right. Then you see the mouth, the way it is. All these are things you buy and fix yourself. It doesn't come ready-made. All right. So that is a coaxial cable. So we're going to see a sample here. This is what I'm talking about. All right. There's always a copper inside. So after the copper, you see the shield there. Then you see this part here. All right. So a coax cable with the outer jacket pulled back to reveal the braided shading and copper core connector. All right. So that is how a coax cable looks like. So we have the RJ6. All right. This is an RJ6 cable. Okay. Then we have what we call the RG59. RG59 cable is thinner than RG6 and has, excuse me, RG59 cables. Okay, they're stopping the recording. Then you have to log back again. They're stopping the recording now. Shown me. So let's stop the recording. Then we'll log in again to continue the class. Thank you. If you have any question, please put your questions together. By the time we come in, we can go through the question. Just see this.